In this video, I will demonstrate how to write a quadratic equation for any pattern as seen below. So if we take a look at this pattern, we can clearly see that as the stages increase from stage 1 to 2 to 3, there is always a change that we are adding 4 every single time. We're adding 4 of those purple tiles. So we can fill in a column that we are always adding 4 purple tiles. The next thing I can do is I can look at the relationship of the blue tiles. For example, in stage 1, my base is 1 and my height is 1. In stage 2, my base is 2 and my height is 2. In stage 3, my base is 3 and my height is 3. From here, we can assume that in stage 4, our base is going to be 4 and our height is going to be 4. Now to calculate the total number of squares in each stage, I can take my base, multiply it by my height, and add 4. So for the total number of squares in stage 1, it's 1 times 1 plus 4, which would give me a total of 5 squares. And that's true by looking at the picture. For stage 2, we can also do that. 2 times 2 plus 4 gives me a total of 8 squares. And by looking at the picture, we can properly identify that, yes, stage 2 does have 8 squares. For stage 3, we would multiply the base times the height, so 3 times 3 is 9, add 4, and we get a total of 13 squares. Now, although we don't have stage 4 pictured, we can assume that this pattern is going to continue, and we will test this in a second. But for right now, let's go ahead and predict the number of squares. So if my base is 4, my height is 4, I'm going to multiply those together to get 16, and add 4 to get a total of 20. By looking at this, I can see and identify that my base and my height are always the same number as my stage. In stage 1, my base is 1, my height is 1. In stage 2, my base is 2 and my height is 2, and the pattern continues. So for any term, we can say that the base is going to be equal to the stage number, and the height is also going to be equal to the stage number. And in order to calculate the total number of squares, we're going to do n times n and then add 4. So we can simplify that. We said n times n plus 4, and we can simplify that and actually write n squared plus 4. Well, let's use that to test our theory. We can test this by using a stage that we're given to see if this equation or expression is true. So for example, if I use, let's say, stage 3, I'm plugging 3 in for my stage number, which is n. I'm going to square that and add 4. By looking at the picture, I should end up with 13. So let's try it. 3 squared is 9, and 9 plus 4 does give me 13. So it works. Let's try stage 4. Let's see if our prediction was correct. So if I'm using the same n squared plus 4, I'm plugging 4 in for my stage number, squaring that, and adding 4. 4 squared is 16. 16 plus 4 does give me 20. So the quadratic function that I can write from this pattern is simply n squared plus 4, where n represents your stage number. If we take a look at this example is unlike the previous example or pattern that we looked at, because in the previous pattern we were adding 4 to every stage. However, with this one, it appears that we are subtracting. So let's start by looking at our pattern and representing it as the base times the height, imagining that this whole thing was filled in. So pretend that there's a block here, there's 2 blocks there, and 3 blocks there. So we always want to relate the base and the height to the stage number. So if I'm at stage 1, my base is going to be my stage plus 2, and my height is my stage plus 2. Because if I'm at stage 1, my base is 1, 2, 3, and my height is 1, 2, 3. And the same is true for stage 2. My base would be my stage number plus 2, and my height is my stage number plus 2. And again, n is representing stage number. So if we look at stage 2, my base is 4, 1, 2, 3, 4. Again, we're pretending that that white space has blocks filled in for right now, and my height is also 4. 1, 2, 3, 4. And the same is true for stage 3. Stage 3 is also n plus 2, and my height is n plus 2. So now let's take a look at that empty space, the space where we don't have any blocks, that white space right there. If we look at this, it appears that every time our stage is increasing, we are removing that number of blocks. So for example, in stage 1, we are removing 1 block. In stage 2, we are removing 2 blocks. And in stage 3, we are removing 3 blocks. So our total change we can write is minus n. So in stage 1, we subtracted n. In stage 2, we also subtracted n. However, in stage 2, n would be 2, signifying that we removed 2 different blocks right there. And the same is true for stage 3. Again, n represents a stage number, and we are removing that number of blocks every time. So if I wanted to find the total number of squares in every stage, I would take the stage number and substitute that in for n, just like this. And I would also multiply my base times my height, because technically it is a square. So for example, my base is equal to 3, my height is equal to 3, and I am subtracting 1. So my total number of squares would be 3 times 3 minus 1. So 3 times 3 is 9, minus 1 gives me 8 total squares. And if I look at the picture, there are 8 total squares in stage 1. I can do the same with stage 2. So again, if I'm at stage 2, I'm substituting 2 in for n, because n represents my stage number, and I'm taking my base and multiplying my height, and then subtracting 2. So for example, 2 plus 2 is 4, 2 plus 2 is 4, and I'm subtracting 2. So I'm multiplying my base times my height, so 4 times 4 is 16, minus 2 gives me a total of 12. And if I look at my pattern in stage 2, I do have 12 squares in that pattern. And I can do the same for stage 3. Again, substituting 3 in for n, because n represents my stage number. I'm multiplying my base times my height. So 3 plus 2 is 5, 3 plus 2 is 5, and I'm subtracting 3. So if I do my base times height, 5 times 5 is 25, minus 3, I get 22. So if I double check stage 3, I do in fact have 22 squares in stage 3. So this shows me that my pattern will continue no matter what the stage number is. So for my base, it's always going to be n plus 2 times my height, which is n plus 2, and then I'm always going to subtract n, and that's going to give me my total number of squares. So if I were to write this as 2 binomials, it would be n plus 2 times n plus 2, and then I subtract n at the very end. What I can do from here is to write it as one quadratic function. I can actually FOIL it. So n times n is n squared, n times 2 is 2n, plus another 2n because I'm multiplying my inner, and then 2 times 2 is 4. But I can't forget about this minus n at the end. So if I combine my like terms, I get n squared, 2n plus 2n is 4n, minus 1n gives me 3n, and then I have plus 4. So there you have it. I can use that quadratic function, n squared plus 3n plus 4, to find any number of squares at any stage number.